Earth. At this time, the earth or soil is rich in nutrients and well suited for agriculture. The climate is warm. In the primeval forests that have grown here for a millennia, deep layers of humus-rich soil have built up. Humus has a carbon content of 60% and is good at holding on to nutrients and moisture. Humus forms as plants, animals, fungi, and bacteria live and die in the ground. Agricultural experiments. Stone Age people go from hunting, trapping, and gathering to living entirely on agriculture. This change takes a long time. Pollen samples show that around 3000 BC, in Vestmanland, large tracts of woodland were cleared for farming and pasture. But pollen samples from a little later show almost nothing. What happened? Perhaps the first agricultural experiments failed. New attempts are made almost 1,000 years later, and this time, agriculture is here to stay. Slash and burn agriculture. One way to create farmland and pastures is to burn trees, bushes, and land on purpose. This is called slash and burn agriculture, and was what the earliest farmers did. To begin with, farming crops have access to a lot of nutrients. However, with CO2 released into the air, most of the humus in the soil has burnt away. And after a few years, the soil no longer contains enough nutrients. Then new land must be cleared, and the forest is allowed to grow back on the abandoned farmland. The crowns of the growing trees are low enough for livestock to eat from them. Much later, the same area may be burnt again for growing crops. From the earth and back. Step 1. Green plants are home to photosynthesis. This is the first step of all food and all biofuels. Using energy from sunlight, the raw materials of CO2 and water are converted into oxygen and sugar. Sugar contains carbon and can be converted into other substances. Food is like carbon-rich building blocks that we are made up of. In addition, food is packaged solar energy that we need. Collaboration. Certain fungi can only survive by cooperating with living plants. Their hyphae, cellular wires, join with the tips of the plant's roots. This is called mycorrhiza. The plant gives energy-rich substances to the fungi. In return, it receives a nutrient called phosphorus that the fungus has extracted from the soil. All living organisms contain carbon. Living mycorrhiza presents a very large store of carbon in woodland and grassland and other perennial agricultural systems. Carbon in the air. We need to release the energy from the food we eat so that we can move, think, stay warm, and grow. In our cells, and when we burn biofuels, carbon-rich substances and oxygen are converted into energy, CO2 and water. The CO2 is released into the air. If more CO2 is produced than plants have recently absorbed, the amount of CO2 in the atmosphere increases. This contributes to the greenhouse effect, making the climate warmer. Carbon in the soil. Carbon-rich humus is what decomposers living in the soil, tiny creatures, bacteria, and fungi, leave behind after using any easily accessible energy and nutrients in the dead material. Decomposers also release CO2, but then again, the resulting humus remains for longer in the soil. Carbon is stored there, and the humus makes the earth porous and benefits organisms living in the ground, which makes life better for plants.